This is the Hugging Face Deep RL course, Unit 4, the advantages and disadvantages of policy gradient methods. At this point, you might ask, but DeepQ learning is excellent. Why use policy gradient methods? To answer this question, let's study the advantages and disadvantages of policy gradient methods. Advantages. There are multiple advantages over value-based methods. Let's see some of them. The implicity of integration. We can estimate the policy directly without storing additional data, these action values that we had before. Policy gradient methods can learn a stochastic policy, while value functions can't. This has two consequences. Number one, we don't need to implement an exploitation trade-off by hand. Since we output a probability distribution over actions, the agent explores the state space without always taking the same trajectory. Okay, that makes sense. Number two, we also get rid of the problem of perceptual aliasing. Perceptual aliasing is when two states seem or are the same, but need different actions. Okay, gonna need some explanation about that one. Let's take an example. We have an intelligent vacuum cleaner whose goal is to suck the dust and avoid killing the hamsters. All right. So the picture here is a symmetric situation where, it can go left or right. Those are both red, and then there's hamsters somewhere at the top. Our vacuum cleaner can only perceive where the walls are. The problem is that the two rows cases are alias states because the agent perceives an upper and lower wall for each. Okay, so here is, I guess these are rows, and the upper is, I guess, this black box, and I'm not sure what lower is. Under a deterministic policy, the policy either will move right when in a red state or move left. Either case will cause our agent to get stuck and never suck the dust. Okay. Under a value-based reinforcement learning algorithm, we learn a quasi-deterministic policy, epsilon greedy strategy. Consequently, our agent can spend a lot of time before finding the dust. On the other hand, an optimal stochastic policy will randomly move left or right in row states. Consequently, it will not be stuck and will reach the goal state with high probability. Okay. Policy gradient methods are more effective in high-dimensional action spaces and continuous action spaces. The problem with DeepQ learning is that their predictions assign a score, maximum expected future reward, for each possible action at each time step given the current state. But what if we had an infinite possibility of actions? For instance, with a self-driving car, at each state you have a near infinite choice of actions, turning the wheel at 15, 17.2, 19.4, honking, etc. We'll need to output a Q value for every possible action, and taking the max action of a continuous output is an optimization problem itself. Instead, with policy gradient methods, we output a probability over actions. Policy gradient methods have better convergence properties. In value-based methods, we use an aggressive operator to change the value function. We take the maximum over Q estimates. Consequently, the action probabilities may change dramatically for an arbitrarily small change in the estimated action values if that change results in a different action having the maximum value. Okay. For instance, if during training the best action was left with a Q value of 0.22 and the training step after it's right, since the right Q value becomes 0.23, we dramatically changed the policy since now the policy will take most of the time right instead of left. On the other hand, in policy gradient methods, stochastic policy action preferences, probability of taking action, change smoothly over time. Okay, there's a smoother change. Disadvantages. Naturally, policy gradient methods also have some disadvantages. Frequently, policy gradient converges on a local maximum instead of a global optimum. Policy gradient goes slower. Step by step, it can take longer to train, which makes this inefficient. Policy gradient can have high variance. We'll see in actor-critic unit, why, and how we solve this problem. If you want to go deeper into the advantages and disadvantages of the policy gradient methods, you can check this video.
Hello and welcome to this 9th lecture in this course on
This is
reinforcement
an hour
learning.
and 38-minute
My
video.
name is Hado van Hasselt and today we will be talking about policy
Probably
gradient.
outside the scope of this video, but I recommend everybody go watch that. Probably very, very good information. So diving deeper into policy gradient methods. I'll make this a separate video. I recommend everybody go and watch this video. I'm sure it's very, very good. And I'll make a separate video. Thank you for joining.